All right. I'm going to create a series of video lectures on chapter one, two, and three, and then I'll do more. It is a little difficult to make these lessons short because of the content. I have about 90 slides. So in this first set of video, this will be like chapter one on security fundamentals. We give We're going to give obviously credit to this company that helped with the 30 Bird Media LLC True You Certify. Of course, this is the title. That's my information on how to reach me. That's the instructor bio on me. I don't want to be repeating it. But here, chapter one, security fundamentals. The whole idea is to help you identify basic security concepts, describe threat sources and threat intelligence, and how to participate in enterprise security planning. So we hope that you learn again the basic security concepts, categorize what's called security concepts, controls, which is really countermeasures, identify key principles of identifying security incident. This is in module A, which is security concept. There are a few, I think it's 4 modules in here. So if I'm talking too fast, send me a message. I'm just trying to make the videos not be too long, but you can always freeze the video and look at the slide deck, right? So when we identify asset, it's just anything that has value to your organization. I always tell people to replace the 2 S's with like dollar signs. And of course, a threat is anything that can harm an asset. So everything in cybersecurity is defined with the CIA triad: confidentiality, integrity, and availability. Confidentiality means having the information available for the person that needs it. Integrity, only for that person that needs it, right? Integrity means trusting the information that is not been altered. And of course, availability, making sure that it's available when you need it. So confidentiality should be seen by only the person that is supposed to be seen. So this is looking at it from, I call it a blue team perspective. If you're looking at it from a red team perspective, you hear about the DAD triad, which is the one for disclosure, destruction, and of course, denial. So it complements each other. But for now, we talk about the CIA triad. So some other core principles include authenticity, meaning that I don't use the word vouch for it, but non-repudiation is a legal term that means that the person cannot deny or repudiate that they did the items, right? And accountability means who is responsible. I want to see what you did on my system. And of course, the privacy, self-explanatory, and then safety. So usually risks, the threats, and availability, these are the definitions in there. Risk usually is a calculation as in quantifiable risk, meaning impact multiplied by the likelihood or the probability. And of course, we already talked about threat. Vulnerability just means weakness as it relates to introduction, the weakness in your system. So these are some standard organizations in cybersecurity, from the ISO all the way to OWASP, right? You can just read this on the screen. But we always use Alice and Bob to talk about cybersecurity. So Alice is going to send a message to Bob. The whole idea is to prevent Eve with the evil eye from seeing it, right? So sometimes in discussion of cybersecurity concept, I want to make sure that we know that we need to balance. Too much security makes the system not as usable. So there's always a balancing act. In the class, we will never have a discussion about these concepts, right? So security controls are basically countermeasures that you put in place. They go from managerial, also known as administrative, to technical, known as logical and operational, and then of course physical. Just managerial means policies, management level. They make up policies. Technical, what I'm going to implement with technology, and operational, day-to-day, and physical would mean stuff like fences, bullets, right? We can also classify security controls by what they do, like preventative, directive, detective, corrective, deterrent. They're almost self-explanatory. Preventing you from entering my system, or correcting after you do something, and of course, deterrent, which sometimes confused with preventive. So I always try to say deterrent is to try and get to you in your mind that you will not do it, and of course, preventive. If you decided to do it, I want to prevent you from doing it, right? So many of the most effective confidentiality controls, just telling you that are not necessarily technologically, they're more like policy-based. So you need to control where your data is stored, confidential data from getting to the wrong hands. There's just a recent data breach that occurred last week. All right, so some of the confidentiality controls from a management perspective would be the doctrine of least privilege, need to know, and of course, separation of duties. Alex and John cannot divide up what they need to do in the organization, which means Alex and Bob will need to collude, or Alex and John will need to collude to commit that illegal act. Right? Some of the technical confidential controls will be access control mechanism, like restrict who gets in, like with smart cards, for example, encryption using some kind of cryptographic function. Of course, steganography, which is hiding something inside something, like hiding a file inside a music file. I'm giving you an overview. For integrity controls, you have like hashing, which is basically, they put it as part of cryptography, but the essence really is to take something and convert it into what's called a specific form, like a message digest, right? And digital signature, will cover this more later on, which is a cryptographic function that involves, it's like my normal signature as a human being, but this is now a digital aspect of it, right? We'll cover them more in details. Of course, backup, version controls, redundancy, having duplicates. So like if I have storage, I have extra file storage. If I have a network interface card, I have maybe extra one, so that if one fails, another one can be used. That's where you now have the doctrine of fault tolerance. They tend to go together, right? So something's going to continue functioning when another one fails. And then patch management, I always make an analogy like I have a shirt on now, and there's a hole in my shirt. I want to patch the hole in my shirt, right? How do I patch the hole in my shirt? I patch it by basically stitching it. So patch management in terms of software security means I am going to implement the recent updates that was released by the manufacturer, right? Cover those more in details in a minute. And then compensatory control basically means when it's an alternative control when the main control is not available. Example would be you're running Windows 7 when you know Windows 7 is no longer being supported by Microsoft, right? So what you now do in that scenario is to maybe have some other kind of control to make up for that primary control not being available. And sometimes it says you use this for regulatory compliance for the law to make sure that whatever your entity or your government requires you to do, that you're in compliance. Again, this discussion slides, you can pause, think about it if you're studying together, or think, why do I need security controls? Which one is more important for my organization, and which one should I put in place, right? This slide is a general definition. If you look on Windows, you go to Event Manager, you see activities on your network, right? Any change in your system basically is an event. It happened at a particular time, I can see it. It doesn't mean it's a bad event, like logging in is an event. But an incident would be like an event or a series of events that are unexpected. Or maybe some unusual thing that can be a threat to your CIA triad, right? So you got event first and then you have incident, right? So this could be how you evaluate events. So look at this table in here, true positive, it really happened, I identified it. True negative, right? The event was not really a bad event, right? It was a benign event, sorry, and then you get an alert. So this is a good result, says everything is working correctly. And of course, you got false positive. You mistook the event for a bad thing, like an attack when it wasn't really an attack. False negative is a problem occurred, but you thought it was not a bad, a bad event. This is bad for your system, really, right? Just giving you a general. So if you take my AI tester course, you will see what I call a confusion matrix. This will relate to that confusion matrix where you see actual versus detected, but just have a general definition of what this is. When I'm also now looking at metrics or indicators of my system performance, Latency is like a delay from when I request something to when I get it, right? Like when you have buffering, that's could be part of latency. Availability, usability, these are almost like self-explanatory, but like scalability, ability to like go up higher. How can I recover from a system? And of course, what's the cost of the fixing my system or the problem in my system, right? So some other metrics that you need to be aware of is like KPI, KRI, and then KCI. You may have encountered KPI, basically key performance indicator. Tells me maybe if I've designated something that's relevant to my business, how is it performing, right? And then for the key risk indicator, it's self-explanatory, the level of my risk. And then security controls will be my key control indicator, right? Then I also have something called a gap analysis. Basically, it's where I am to where I want to be. And I'm checking in the middle to help me improve to get to my target, right? And then this one, trend analysis, is basically looking at what's happening over a period of time, and that should help me to anticipate if there's going to be a problem before it occurs, so I can have enough time to address it. We use this even like looking at threats or something. What's the trend in the industry, so I can try and fix it, right? So simple question. Someone put malware on your computer that records all of your keystroke. What aspect of security was primarily attacked? So choose the best response. So how you analyze it is what someone's going to see that they were not supposed to see. That means the answer should be A, right? Oh, what type of control will the security assessment procedure be? Right? Choose the best answer. I have an assessment procedure. What does that mean? Is it a managerial, operational, physical, or technical? And the reason why this is operational is like more like what I'm doing on a day-to-day basis. Some of these questions, if you get it like in an exam, some is more than one might seem right. You're looking for the one that is most right or best right. But all right. What is the metric that is most appropriate as a key risk indicator? Choose the best response. So this one you sit down here and you analyze it. So employee phishing awareness training, false positive rate for endpoint security agent, number of concurrent users in a network, percentage of system upgraded to the latest patch level. We can debate this. I've had some of these questions, look at it with my colleague, and we're like, which one is right, which one is wrong, right? But use a process of elimination to get to what you believe might be correct, right? So now, this one is tricky. Your security program alerts you of a failed login attempt to a secure system. You do the investigation, you learn that the system's regular user accidentally has their caps lock on. Believe me, I've had this about over 15 years ago when I was like a desktop or help desk technician, right? This is a very common issue. What kind of alert was it, right? Choose the best response. So when you analyze this in here, is it a false positive, right? So because you're looking at the log, say, oh, this person logged into the system, and you're thinking maybe it was an attempt to hack into your system, right? But the guy just forgot. So that's basically a speed version of module A. So in module B, this is part of the same chapter 1. You need to have an understanding of threats. Okay, what is happening on my network, on my system. So here, categorize the attacks by motivation, identify the threat vectors, their impact, and some cybersecurity threat intelligence, right? So in this chapter, there is no labs. We're using U-Certify because it's an introduction. But when we get to chapter 2 and more, we start seeing our labs, which I would do the demos for you in the lab. And because of space, I might put it on YouTube, and then you can access it on YouTube. So adversarial, this is somebody bad, right? Accidental and error. Structural, like failure in hardware. Most people don't even see this as a type of threat, but it is. Or environmental, which could be like a natural disaster. This is not man-made, right? Maybe environmental, sorry, this was environmental as in power or network access. So let me go back to this slide for a minute. Let's talk about the sources of threat. That's what this is talking about, okay? I will also include, so we differentiate man-made and natural disaster. So on this next slide here, we will now start talking about people who are hacking our systems. How do we classify them? So because of sensitivity, some of the terminology have changed from like black hat, white hat to authorized or unauthorized. So if you're an authorized, you're black hat in those days, right? Trying to do bad. If you are authorized, you're white hat, like an organization person, right? And of course, if you're in the middle, like somebody who's trying to hack into a system to provide a proof of concept, like what we call a bug bounty hunters. They don't really want to harm your system, but you didn't give them authorization. So this one is kind of like sensitive and be sure that you're not going to go to jail. Make sure before you try to do anything like that, right? Okay, just uh, be careful when you're doing that, right? We say don't hack a system unless you're authorized fully. So the whole idea is what makes somebody hack my systems, right? What are their attributes? So we look at what is the driving force behind them, their sophistication level, like how technically inclined they are, where they get their money from, where they're located, um, how they're trying to track into your system, right? But the point is that whatever the reason, whatever those are, people want to make money, they want to spy on your system, they disagree with you, what you stand for, political parties, or if I am a animal lover and so maybe I'm a vegan and you eat animal, right? So maybe I want to attack you, or I'm a anti-abortion, your abortion clinic, this kind of stuff, right? Because ethics, blackmail, revenge, disruption, chaos, and war, hybrid warfare. Of course, data exfiltration, meaning I want to steal the data from your network, and maybe I just want to even just disrupt your system, right? We can classify our hackers based on maybe uh, I call this more like knowledge. Also, it could be because of script kiddies are guys that just load and buy tools and try to use it, right? Criminal syndicates, shadow IT. The big one you need to worry about is APT, advanced persistent threat. They got a lot of skills and they stay on your network, right? But let's go back to the previous slide so we can distinguish here. This one was about motivations, right? Now we now talk about classification of them, maybe based on their knowledge. So you can see that these two slides are related, right? But um, when you're thinking about how people can attack your network, the vectors, which means the pathway, could be maybe they have a direct access, they can use wireless or wired. Of course, email is always a good one. I send you an email because people are always going to click, right? Social media, because people are using media, and of course supply chain based on, you buy something from a manufacturer, don't know that inside the software is some kind of malware. Of course, USB removable media and cloud services using AWS, Microsoft, you don't know that could be a way for them to attack you, right? So there are just many ways that attackers can get to you, right? I'll call it the vectors for attack, right? Our newest one, I have one module on AI and cybersecurity, but this addresses it briefly here. If the training data for AI is tainted or not diverse enough, you can have issues, right? If the algorithm has some problems, so this one becomes a sophisticated attack on like machine learning or your AI modules or your training data sets, right? Uh, when we are talking about attacks, third-party risk could be I have a contract with somebody and I am employing a subcontractor. This could be also vulnerability for my network. So just understand, especially when you're working with other individuals and you're part of a contract or something, right? So what could be the impact of a breach or an incident? Loss of availability, the money is going to cost me to recover, information disclosure, identity theft. I have personally been a victim of identity theft, so I know how violating it could be. Financial cost, reputation, and of course, the legal consequences. Somebody's going to sue you. So when you're discussing this portion, think about the types of threat actors, the threat vectors, and the impacts of a threat being successful to your organization. What does that mean to you, right? So how you can become smarter or have more, I'll call it threat intelligence, including using for the CTI, like evidence-based knowledges that help you to look at emerging threats so you can become a little more robust or your systems could be better, right? So there's a lot of data that you need for threat intelligence from multiple sources, um, external sources or whatever. But the point is that final phase is after you get all this information, you need to act upon it, right? You need to do something about it. Just gather the information, right? So threat intelligence is a specialized area where I do a lot of training on, like for law enforcement or other entities on how to use threat intelligence, right? So for our threat intelligence, just understand that to be aware of threat intelligence, you could have obviously the known threats, current vulnerability, looking at trending attacks, what is like happening in the industry. So because they might adopt new technology strategies, right? You just need to know what's happening. That's why you need to read a lot and subscribe to news feeds. The emerging ones too. It just says that because technology is changing too, of course, business changes too. There could be a lot of newer threats that are going to affect your security landscape. 0-day just means a vulnerability, an attack that we don't have any anti-malware, right? Because we've not discovered it. We discover it the day that it hits the market. That's why it's like 0-day as opposed to day one or something, right? Many times you hear in the news about that, right? So for you to figure out how to get involved in threat or how to gather information, you need to know your requirements, collect your data, analyze it, disseminate it to your decision makers, and of course, you need some kind of feedback to improve what you're doing, right? A good source for intelligence information is open source. People don't even understand the amount of information available out there because we live in an interconnected world out there now. So there's so much information out there. This is free to people. Google is a great source of OSINT, right? Of course, the other source will be closed source, or proprietary intelligence, which is basically you have to pay to get it, right? It's an exclusive thing, but you can get so much from OSINT, and then what you cannot get from OSINT, you can get from CSINT, right? So just know that so many ways to get information. But some other sources will be vendor websites, social media, academic journals, attending conferences like Black Hat, GTech, news stories. I get a lot. That's how I knew about the TransUnion attack last week. Of course, you need to belong to communities. This one about attackers, if you're going to do a lot of undercover work, you need to join forums on the dark web, right? So you can get really, really good information, depending on which part of the world you're in, right? Information sharing organization, these are CERT, SAC, MITRE is great. We'll cover this more later on, right? But besides that, you can also classify them in terms of internal, some database for repositories, right? Information. You got threat maps, because I mentioned the dark web, of course, predictive analysis of what's happening in the industry. How do you disclose a vulnerability? I think I have another video on bug bounty or why we need this. After teaching this or training for a while, but just check the YouTube channel. There is a video I have on how we disclose vulnerability. All right, so if you discover a vulnerability, you should inform the vendor, the person that manufactured that hardware or developed that program, right? So normally after you've told them, you wait for a reasonable period to see if they fix it. If they fix it, then you can disclose it, right, in a coordinated process, right? If they don't produce a timely fix, then you want to disclose it to the public, right? So that users are aware of the risk. This would be a good approach. You go first, tell the guy you don't want to fix it, and you tell the public so we're not victims. But of course, the danger of that is the bad guys now know about it. So there'll be like a rush to take advantage of it, right? If you ever watch like pirate movies, you will see the flag. If you like Pirates of the Caribbean, right? So how do I know that somebody is responsible for a hacker or attribution? There's all those things like false flag doctrine, but here, reputational indicator, if I know a source based on their reputation, I can know that that might be that person, right? Or how the behavior, or see IOC, which is usually like an artifact left on my system that's associated with some kind of malicious activity, right? And of course, vulnerability can be exploited. This is just where I can try and say this is an indicator that a threat on my system, right? This is very important. How do you spot indicators, spotting indicators, documented indicators? Account has been locked out. That should tell me, hey, something is happening, right? If we've got two sessions in parallel, that might be an issue, right? Impossible travel doctrine just means I just use my card in Abu Dhabi. And it takes me around 15 hours to fly from Abu Dhabi to Miami. If my card is being used 3 hours later in Miami, that means something is wrong, right? They've not invented a plane that can get to Miami in 3 hours. Of course, there's some exceptions, like with Apple Pay, maybe you have any family member use it, but generally, impossible travel doctrine helps you spot some kind of, right? Of course, block content, missing logs, this kind of things. This is just giving you an idea, it's an overview of how you can be saying to yourself, something is wrong going on, right? So look at this automated indicator sharing. If you see on here like poison ivy, like a fire hash for poison variant, MITRE Corporation, say, hey, this looks like bad one, right? This is just an overview. Then let's see right? So they also have this one called the attack frameworks, all right? So you've got the diamond model of intrusion and then MITRE attack. All it talks about normally go from recon all the way to action on objective, that level number 7, okay? So this is actually, sorry, let me fix this slide because this is the cyber kill chain. That's what this first one is, right? So let's continue on our slide. So cyber kill chain shows this process it's from the military. How do you do your recon, you weaponize it all the way to fulfilling what you want to do on that. There's an awesome lab on Try Hack Me on this. Again, this is an overview, right? What category of attackers are defined by their limited sophistication and reliance on pre-packaged tools? Script kiddies, they just buy it, okay? What kind of attackers and APT most commonly associated with? Now, be careful about this question because this is general nation state, but we now see that even criminal organizations could be APT also, right? Which categories of attackers might also be called cyber terrorists? Choose the best response. Hacktivists, because obviously based on their ideology, right? Which are the following examples of open source intelligence? Choose all that apply. So B meaning alien bot, a criminal group, because I can see it, right? Latest vulnerability entries in the National Vulnerability Database. We'll cover those later on. Of course, if I have a CVE, which is common vulnerability exposure numbers, we will talk about those hopefully later on, right? A coworker detects a social engineering attack because the return address is a domain associated with a scammer. Which kind of threat indicator is this? Choose the best response. This is reputation of that organization, right? So that was module B. So enterprise security strategies module D. This is also still part of chapter 1. I know it's long, so just bear with me. So here, describe security governance and regulation, identify relationships between security practice and organizational structures, and of course, apply defense in depth in security planning. All right, so here, when we're talking about this, security governance, corporate governance, GRCs, IT. So basically, most organizations, right, need to have a strategic plan, tactical plan, and operational plan. Strategic plan is more like a business-wide plan because the tactical one is the mid-level plan. You got the operational one. Whenever you see operational, think day-to-day, plan of the organization, right? So when I'm thinking about this, what about compliance with regulations? This is a big issue. So GRC helps me with a formal procedure to make sure I comply with the regulations of my industry, right? Because consequences will be fines, sanctions, of course, loss of my license, loss of my reputation, and of course, increased scrutiny. That's why you see a lot of people are afraid of GDPR, right? The fear of GDPR is like the beginning of wisdom for some people. Some organizations or laws related to compliance, SOX, you hear the SOX, FISMA for federal agency, HIPAA for health in the US. FERPA covers a lot of my work for university students, right? Graham Liam, GDPR, I just mentioned it, and then PCI-DSS, if you accept debit or credit card, you're governed by that, right? So this is just a little table on a PCI-DSS, what you're supposed to do, the controls that you should have in place, right? Just maintain an information security policy, build and maintain a security network. So pause, look at this briefly, right? And then move on, right? This is confusing for some people. Due diligence and due care. For me, it's easier to wrap it around because, from my training as a lawyer, due diligence before you sign a contract or do something, right? Investigate the situation you're entering into. Due care says this is less about research you put in ahead of the time and more about ongoing actions you perform for whatever assets you're responsible for. In law, if you get sued for negligence, you say lack of duty of care or breach of your duty, right? It would be like negligence as a tort, T-O-R-T, right? Compliance monitoring, could be internal or external, right? Many people build a career as external compliance monitors or auditors. And then you have reporting, right? How do you do the reporting? You have an acknowledgement, like a formal statement recognizing a condition. Attestation is also another formal assertion that some statement or condition is true by the person who is responsible for that. So security governance in itself is at its own separate certification. A lot of lawyers get involved, a lot of actuary people, right? But let's switch gear, talk about privacy, right? This is a good distinction. It's not the same as confidentiality. It just means you must restrict access to private data while still making it available to the people that are supposed to see it, right? So you say private information belongs at least in part to the data subject. That's the person that it describes, right? So privacy protection can also vary depending on the person that is covering. Whether it be HIPAA, a lot of things talk about the private data. Just be careful about GDPR and make sure you know what to try to do. For GDPR, it has like 3 rules: data subject, data controller, data processor. Each one has different meanings. And GDPR covers even if you're not operating in the EU, but you are dealing with data involving EU citizens, okay? So that's the definition. The subject is the individual. The controller is the person that controls the data. The processor is the person that handles and processes that PII, which is the private or personally identifiable information, PII. All right, so if somebody, if you're handling the data and there's a breach, what do? You need to notify individuals. There are very strict rules, like in the EU, there are very strict requirements for notifications, right? US is a little lagging. I've been involved in laws in UAE and Nigeria. Believe it or not, those 2 countries are even more ahead than the US, but the EU is very advanced, right? When somebody has maybe got information like dealing with your social security number, your national ID number, your Emirates ID number, your driver's license, credit card number, medical ID number, you need to notify them. So when we're discussing privacy, we're talking about balancing privacy again with security, balancing privacy with what your organization wants to do. So responsibility for data or privacy in organizations, you have all these roles. You have a manager, professional, user, and of course the auditor, right? Usually the auditor is reviewing afterwards. The security person, obviously, the person that is handling it, and of course, the manager is the overall person that is responsible. If you ever seen what's called a RACI matrix, RACI, just think as it relates to this, right? All right, so today, in many organizations, their roles and responsibilities have become like kind of like merged, and it could be confusing, but generally you have a CISO, CSO, CTO, CCO, CAIO, but the CISO generally oversees the general aspect of security, and it works under the CSO. If there's no CSO, under the CIO, this Chief Information Officer that oversees the whole IT operations, right? The Chief Compliance Officer or sometimes the Chief Privacy Officer is more specialized based on privacy and stuff, right? Right. So corporate governance structures, you have a board of directors that oversees the information, right? And then, of course, they delegate down to CEO and starts going down to. So if you see like an organizational chart, you need to pay attention. When you're thinking about this whole idea, just think who is really ultimately responsible and who has been delegated to handle that information, right? But to have a robust policy and to make sure it's enforced, you need to make sure that you have enough money for it funded. You have to do periodic audits. You have a reporting procedure, right? To make sure a violation, when you occurs, you are compliant. All right. So just understand that this discussion is about maybe deciding who is ultimately responsible for a data breach in your organization. How do you decide that, right? So this is a good doctrine. Think about a bullseye or that. So defense in depth, it just means I'm going to have layered defense to make it difficult for the person to hack my organization, right? So this chart is going to be, I got my data, I've got my application, my host, all the way down to the users and organization. Each level requires some kind of security implementation. So today we need security by design, right? Not by default, right? Or afterthought. That's why now DevOps is now part of DevSecOps, right? So secure by design just means that the developers include security inside, right? To minimize the bugs. Because this is just self-explanatory. This one, security through obscurity, is no longer very valid in the industry. And it uses security technology or features that are not standard or hidden. People don't believe that you need to hide like the technology you're using, right? And of course, open security is what most people are. The technologies, methodologies you use are known quantity based on openly published technologies that anyone can inspect or dissect. That way, you get contribution, right? Some people are opposed to this, but just understand the difference in the theory. One, I try to hide what I'm doing, right? One is I tell everybody what I'm doing, right? So this one, it's balancing security and usability. The system is too secure, it might not be usable, right? But when you stress one of the three too much, at least one of them suffers. So when you're thinking about security, usability, of course, inexpensive design and issues. Most of the time, the debate is between security and usability. Right? If I ask you to give me 20 character password, it's very secure, but how usable is it for an average person, right? In terms of just generally looking at security, just communicating the importance of security for organization is very important. That's why many organizations, every time you log on, they say big banner, security is everybody's responsibility. Just saying that if you phrase it in a language that people understand based on their area of expertise, is more likely for people to comprehend it and practice it, right? So sometimes an issue about convincing management until something happens, probably with hardly of resources. But thankfully, a lot of people are beginning to understand the importance of cybersecurity, just like with cybersecurity insurance. Again, this is just another discussion about security strategy. I just linked it in there. A little quick question in here. Here, the answer to this one is to help you with due care, right? The best response, if the law demands more robust protection for your customer base, right? You research database, you're taking your due care. this one in here, I'm trying to make the video not as long, right? You have protection of your system from internal attack by a Cisco firewall, right? Automatically, I'm thinking about that. I'm using a vendor, but then I now suggest using Fortinet firewall between the Cisco and your trusted local area network. Basically, if you are aware of cybersecurity, you know this guy is talking more about DMZ, demilitarized zone, or screen subnet, like trying to set up something like that, right? So then the space between perimeter network. So this guy is doing defense in depth, but also you're now using vendor diversity because you're buying from Fortinet and you're also buying from Cisco, right? Your business is marketing online services to EU customers, so you're verifying GDE compliance. Which of the following parties is most likely a data processor under the law? The cloud service provider would be this one in here. If you have any question, you can send me a question and let's analyze why is it not one of those other guys, right? Here, if you're using it's about medical records, right? So don't get lost here, okay? Medical records, automatically, health records, right? Okay? There's nothing here about using money or federal government or about education, which is fair cost. So automatically, we're talking about health, HIPAA here. Here now about the government, you're going to do your due diligence, and of course FISMA, because it is what U.S. government entity. All right, so if you have any question on these ones, please let me know. But by this one, we're hoping that security fundamentals, you can identify CIA triad, talk about threats, speak the language, think about security governance, like multi-level planning, who's responsible, defense in depth. So watch part of this video. Or if you're one of the students at the university, you have the other slide deck. Look at the slide deck and send me any questions, right? I'm going to try and release the videos as time goes by. Some of these videos are long just because we're covering multiple modules inside each chapter. But what you could do is, if you have a problem with a particular concept, just go to that part of the concept in the video and then move on ahead. And then hopefully this video has helped you. I try to do micro teaching series, but sometimes it's not possible to do that. So enjoy the rest of the course or the rest of your cybersecurity career and concepts.